This is the Biomedical Imaging and Biosignal Analysis Lab, or BIBA. We work with Dr. Greg Bashford, and we do medical imaging, mostly ultrasound, and that ultrasound is mostly specialized to ultrasound of the brain, although we also look at things such as stiffness of tendons, trying to predict when tendons might be nearing an injury, or the elasticity of the heart, trying to look at heart health. We do everything from going to the clinics and doing experiments on people there, trying to figure out new ways to use ultrasound, to processing ultrasound image data and finding better ways of making good images that are useful to doctors, to building ultrasounds. To give you an example, we had an opportunity to go up to the Children's Hospital in Omaha and work with doctors who were doing heart surgery on infants who were born with congenital heart problems. And we were monitoring blood flow in their brain during the surgery to see if there were bubbles of air getting into their brain that we know shouldn't be there because they might be causing like mini strokes, essentially. As a part of that experience, we had also got to interact with the families of these children and make some meaningful connections that way. And we're hoping that our research will eventually help improve outcomes and long-term effects for infants who have this type of surgery. So here we are in the Biomedical Imaging and Biosignal Analysis Laboratory. I'm going to take you into our ultrasound scanning room. So this is Nate, and he's showing us his carotid artery on ultrasound. That's the pulsating that you see right here. The blood's flowing along his neck and up into his brain. Blood flow in the brain is one of the major research areas in the BIBA Lab. It's important for all sorts of conditions such as Alzheimer's disease and stroke. Most of our research is done on another machine which just looks at blood flow in the brain, but the principle is the same as this ultrasound machine. This lab is the only biomedical engineering lab in the BSE department which routinely goes out and works with doctors, clinicians, and patients in hospitals. In that respect, we're very translational. Okay, so now I'm going to show you Mary. She's using a special type of ultrasound called transcranial Doppler ultrasound to look at the blood flowing in her brain. So she's got the ultrasound positioned on the side of her head right here. It's sending sound into her brain, sounds being reflected off of blood flowing in the major arteries in her brain, and we can see a signal on the computer showing the speed of blood flowing in that artery called the middle cerebral artery. And as I mentioned before, we can use this to tell things about people such as whether they may have a greater risk of developing Alzheimer's disease, whether they're having a stroke, and we can also use this during heart surgeries to tell if there's things getting into the brain that shouldn't be there, such as bubbles of air or plaque or pieces of tissue.